So our topic for this lecture is arithmetic mean, or simply we call it mean. What is arithmetic mean? Let's say we have these data x1, x2, x3 up to xn. For example, we have a class in which there are n number of students, and these are the marks obtained by those students. So we have these data x1, x2, x3, xn. What is the total number of data? It's small n. Then arithmetic mean, it's written like this: x bar is defined as x1 plus x2 plus x3 so on up to xn by n. This is arithmetic mean, the very basic definition of arithmetic mean. In mathematical notational form, we write it like this: 1 by n into, this sign is of summation. Summation I equal to 1 to n xi. This means x1 plus x2 plus x3 up to xn. So this can be written as this. This is notation. So this is arithmetic mean. Let's see a small example to understand. Let the marks obtained by 5 students in a class test be 5, 6, 5, 8, 9. Okay. What will be the arithmetic mean? What will be the mean of the marks? This will be 5 plus 6 plus 5 plus 8 plus 9 by 5. So this is, so this comes to 33 by 5. So what is this? Multiply numerator and denominator by 2. You will get 66 by 10. Now you can easily write it as 6.6. So this is the arithmetic mean. Now we will see arithmetic mean for discrete frequency distribution. What is the meaning of discrete frequency distribution? Let's say we have 100 students in a class. Let's say we have this as marks and this is frequency, that is 50. Let's say 30 students have obtained what marks? 50. Let's say 20 students have scored 60. Then 40 students have scored 70. So this is 30 plus 20 plus 40, 90, and remaining 10 students have scored 80. This is frequency. This is discrete frequency distribution. That is frequency. This is frequency corresponding to a data. So this is discrete frequency distribution. This is not continuous. This is discrete. So how we calculate arithmetic mean of this type of data? We calculate it like this. It's done by x1. Let's say the first data is x1 and its frequency is f1 plus x2, f2, and so on up to xn into fn. By what we do? We add all the frequencies. This is the formula for arithmetic mean of a discrete frequency distribution. So this can be written as in notation form. This can be written as sigma I equal to 1 to n xi fi by sigma I equal to 1 to n fi. Okay, let's find the arithmetic mean of this distribution. How will we find? It is this into this. So let's write it here: xi into fi. 50 into 30, what is it? 1500. 20 into 60, it is 1200. 70 into 40, so this is 2800, and this is 80 into 10, 800. So this is x1 f1, this is x2 f2, this is x3 f3, this is x4 f4. Now we add all of them. This is the definition of arithmetic mean. We add all of them. So this is 1500 plus 1200 plus 2800 plus 800 by We add all the frequencies. What is this? 30 plus 20, 50 and 50. This is 100. So by 100. What is this? So this comes to 6300 by 100, which is equal to 63. So the arithmetic mean for this discrete frequency distribution is 63. So this is how we calculate discrete frequency distribution, arithmetic mean of discrete frequency distribution. Okay, we just saw arithmetic, how to calculate arithmetic mean for discrete frequency distribution. But what happens if the volume of data is very large? It's very difficult to take x1 plus into f1, then x2 plus x2 into f2. So this becomes very cumbersome. This data becomes very large. For example, we were just taking x1 f1, it was 1200, 1800. This data becomes very large, and addition of those data becomes a cumbersome process. So there is a shortcut method. The name is shortcut method. What we do, we take an arbitrary constant. Let's say that constant is a. What can that number be? So if we have marks from 50 to 100, so randomly we know that it would be, the average mean will be around 60 or 70. We take 65 as the arbitrary constant. So we try to approximate that value. You can take any value. You can take 200. You will still get the result. But your your calculations will become easier and easier if you take the arbitrary constant around the average. So we take an arbitrary constant, and from there what we find? We find the deviation. We have xi as the data, this is the variable. So this minus a is called deviation. What is xi? x1, x2, x3, x4. So for example, if we had seen 50, 60, 70, 80. So xi is 50 or 60 or 70 or 80. And if we have taken a as 65, then for x equal to 60, 60 minus 65, that will be minus 5. So this is deviation. So we take di as xi by a. Then our arithmetic mean will be, I am not deriving the formula. These are given in your textbooks. You can, if that is of any use to you, you can derive it from your textbook. You can see it in your textbook. I am explaining to you, I am just giving you an understanding of the central tendency. So how we calculate arithmetic mean by shortcut method. If di is xi minus a, then arithmetic mean is a plus 1 by n, this fi di, I equal to 1 to n. What is fi? It is the frequency. Di, it is the deviation. N, what is n? N is when we add all the frequencies, f1 plus f2 plus f3 up to fn. So this is the definition of arithmetic mean by shortcut method. I think this is clear to you. If not, let's do a small example. 50, 60, 70, 80. This is the value of the variable. So this is xi, and frequency associated with it, let's say small, let's take small values. So let's take 2, 4, 2, 3. Okay. Let's say our a is between this, let's say 60. Our deviation is a is 60. So what will be di? Di is xi minus a. So this is 50 minus 60 minus 10. This is 60 minus 60 0. This is 70 minus 60 10. This is 80 minus 60 20. Then what we do? We add fi into di. This is f1 d1, f2 d2. So let's take fi di. Fi di. So this is 2 into 10 minus 20. 4 into 0, 0, 10 into 20, 20, and 20 into 3, 60. So we have taken fi di. What will be this value? f1 d1 plus f2 d2 plus f3 dt d3 plus f4 d4. That is addition of this. Very simple. This cancel. This is only 60. So we have got 60. What is n? Addition of our frequencies. 2 plus 4 6. 6 plus 2 8. 8 plus 3 11. So n is 11 and a is 60. So what will be our arithmetic mean? A, that is 60 plus 1 by n, that is 1 by 11 into summation this thing 60. See, you can take the value 60 by 11, so it will be around something 11 5 ja, so this will be around 60 plus 5 point something, so this will be equal to 65 point, let's say xyz something. So our calculation becomes very easy. This is calculation of arithmetic mean by shortcut method. Now we'll see how to find arithmetic mean by step deviation method. We had just seen the shortcut method, but what if the data is grouped? Then that was for discrete frequency distribution only. So if the data is grouped, that is we have classes 50 to 60, 60 to 70, then how we will take the arithmetic by step deviation method? See what we do. By step we take di, there our di was xi minus a, here we will take it as like this, xi minus a by h. What is h? H is the class interval, 50 to 60, 60 to 70, so the class interval is 10, this is h. Now our arithmetic mean becomes a plus h by n, and then summation I equal to 1 to n fi di. So this is the calculation of arithmetic mean by step deviation. Let's say this is our class 10 to 20, then 20 to 30, 30 to 40, 40 to 50. So we have these as classes. When we have a class, we take x as the mid value of the class. So if this is 10 to 20, x will be 15. This is 25, this is 35, this is 45. Okay. Let's say the frequency associated with this is 5, 4, 3, 4. Okay. We have h equal to 10 here. What we have to find? Fi into di. What is di? Let's say our a is 30, just for example, or let's say the midpoint will be around 25. So let's say a is 25. Then what is xi minus di? xi minus a, not di. Xi minus a by h. H is 10. So what we'll write? We'll write x minus 25 by 10. This is our dA. So what it will be? See, x is 15 minus 25. That will be 15 minus 25 is minus 10 by 10. So this is minus 1. Then similarly you can find 25 minus 25 0. So this will be 0. 35 minus 25 is 10 by 10, so this will be 1. 45 minus 25, this will be 20. 20 minus 10, 2. This is very easy. 1 1 gone. This is 2. What is our arithmetic mean now? This will be equal to a, that is 25, plus h, that is 10 by n. N is 5 plus 4 9, 9 plus 3 12, 12 plus 4 16. 16, and then this addition, that is 2. So this is 8 5 4. This is 5 by 4, 26.25. So we get arithmetic mean as 26.2. So using this, using di, the deviation, calculation becomes very easy. So this is about arithmetic mean.